Just going to finish off with a look at what we call the primitive function. And to solve this, I guess, say it's the reverse. We know the equation of the tangent. What was the original function? So normally we'd have the function and we say, let's find the equation of the tangent. Well, what happens if we go the other way around? So the primitive function is the original function it came from. Well, we know that when we differentiate, we would have subtracted one from the power. So if we're going back the other way, if we're talking about polynomial, we would add one to the power. So that'd be power n plus 1. When we differentiated, we multiplied by the power, but it was the power of the original function. So therefore, when we go back the other way, we divide by the power, but again, has to be the power of the original function or the primitive function, so it would be n plus 1 we're dividing by. So the way I tend to think of it is add 1 to the power over the power. Just think of it that way, add 1 to the power over the power. So if I've got that the derivative is 3x to the power of 4, then I'll add 1 to the power over the power. So it'll become 3x to the 5 over 5. I could have several terms, but each one of those I'll add 1 to the power over the power. So I'll get x to the 4 over 4, x to the 3 over 3, x to the 2 over 2. Now the constant 2, remember there's actually x to the power of 0 sitting there. So you add 1 to the power, x to the power of 1 over 1. You'll notice with both of these, I put in a plus a constant number, because that's the thing we don't know. It is quite possible there was a constant number there, because when we differentiated, the constant became 0. So unless they give me more information, I don't know what that constant is. Now, it might turn out it's 0 and it's not there at all, but I need more information for that. So let's find the equation of the original curve then. We got that additional information I'm looking for. It goes through the point 1, 1. It has a gradient function of 2x plus 3. That's just a fancy way of saying the derivative. Because remember, the derivative is the function that allows you to find the gradient. So the gradient function is the derivative. So they're telling me that dy dx is 2x plus 3. So to get back to the original function or the primitive function, then add 1 to the power over the power. So x squared over 2, but the 2's cancel, so we'll get x squared. 3x and some constant. But now I can use the additional piece of information. Goes through the point 1, 1, substitute in, constant turns out to be negative 3. So there's my original curve. The equation of the curve was x squared plus 3x minus 3. Okay, 4J.